Hi, good afternoon, and thanks for dialing in into YOW Perth. And thanks to Aino for the great introduction. I hope I can really say something interesting about just about everything. Well, in this case, I just need to say something interesting about building and operating platforms. It's become a little bit of a tradition for me to have brand new talks for YOW. It's something that I do enjoy because it's a great audience. It's a great place to get feedback. It means the slides are not always sort of as polished as they are normally, but it guarantees you to actually get content that I haven't shared anywhere before. And that this time is my thinking around platforms. And as Aino alluded to, my interest is really to be an architect who's not sitting there drawing diagrams, but to be somebody who helps us think more clearly and connect the different levels of the organization so that the engine room architect who snuck into the penthouse can actually make sure that the penthouse understands what we do in the engine room and why we're doing it, and likewise to make sure that the engine room actually does things that support the business strategy that's defined up in the corporate penthouse. So my goal, my objective on this is to actually write a series of books that do that. Right? As Aino mentioned, I've written the Software Architect Elevator and the 37 things one architect knows about transformation. So that all hints at forging the connection between what's going on with your business and your strategy and your transformation, and what's going on with your technology and your technical architecture. And my ambition, my future ambition is to shape that into a series of books that actually forge this connection. So one of the books, the Cloud Strategy, that's been out for a year. I have kind of a book like this. So that is all about a new look at cloud and how we understand what's really behind it and how it influences both our organizational as well as our architectural decision. The talk today is a preview into the next book in the series that I'm writing. It's not yet published, and that is called Platform Strategy. If you find this topic interesting, it's a URL. It's at leanpub, leanpub.com/platform strategy. And you can basically right now you can register to be notified when the book is actually published. It's an incremental publishing platform, so you will be able to follow along as the book actually grows and matures, and you'll be able to nag me to make more progress to actually finish the book. So today it's about platforms, right? Maybe, hopefully one day I'll be able to write about API strategy and data strategy, but today it's about platforms. And I want to look at platforms from three angles. The first one is to look a little bit back at what does it mean to think like an architect? I'm an architect by passion. Sometimes I'm an architect by title, and I'm convinced it's not something that's on your business card. I'm convinced that it's something that is actually a way of thinking. And then I look tiny bit at cloud to see how this way of architectural thinking applies to cloud. And we'll find that one of the key things there is the platform aspect. And then we'll dive into it's like, well, how does this platform thing actually work? What is behind the buzzword? So when we look at what architects do and how architects work, the first thing that comes to most people's mind is that we draw pictures. So I know picked on that as well. But when you go online, you say, okay, what kind of pictures do architects draw? You see mostly those kind of pictures. And actually, I want to defend picture drawing for architects because pictures or diagrams are models, and models are a great way to deal with the complexity that our world inherently has. I always say in the last decade or two, we've advanced technology a lot, from cloud and serverless and IoT and machine learning, whatever have you, but we haven't made it easier. Right? We haven't made it simpler necessarily. We can do things we weren't able to do before, but things have also become a bit more complex. The same is true in the business environment, right? A lot of moving parts. So diagrams are very useful. Well, the question is, what diagrams should architects draw? So if you go online, we say like architecture diagram, you're going to see these typical pictures, some boxes and lines. Now, we all know that the comparison between software and IT architects and building architects isn't always matching, but in this case, I think it can give us some inspiration. And that is when you look at rather famous building architects, they do not draw the blueprints. They actually draw like this. So, and you might say like, oh, what is this? Like some napkin sketch, I could have done that. Well, the short answer is probably you could not have. Well, me neither, right? Because this is a design by Frank Gehry, right? A very famous architect. And this is one of the original sketches for the Guggenheim Museum in Bilbao, Spain. Now, you might say, and why is this something he could have drawn and not you or I? And that is because this little napkin sketch is actually fairly special. It makes the key decisions. It emphasizes what is important, right? The key design of this building, and it leaves out all the little details that can be filled in later. So it is, in fact, a model. It is an abstraction that chooses a very important emphasis. It also takes into account the context of this building. This is not a skyscraper or some sort of Las Vegas tower or something, right? This is in an older town. This is by the waterfront. So it's something fairly organically shaped and by the waterfront, right? It has a bit of a horizontal layout, a bit flowery kind of style. So it's actually a lot of thought behind this sketch. Now I believe we can learn quite a bit from this, that famous architects don't draw the blueprints. And if you want to be more blunt about it, the highest paid architects, they actually sketch more than drawing the blueprints. The blueprints are somewhat mechanical. There's a lot of rules and guidelines around it, how to do that. But making these initial sketches, defining the gestalt of the system that's going to be built, that is where the architects actually shine. And if you wonder whether this actually translates into reality, there is good news. This is the best overlay I could do. On the left, there's a bit of a bridge that didn't quite stretch out. But you can see in the end that the translation from the sketch into reality, the key elements were actually there. The organic structure, the horizontal layout, the part in the middle, and on the left, there's a bridge where the pillar ultimately ended up. So these early architecture decisions find themselves in the implementation, but the architects look at the big picture and make sure it fits into the context, the purpose, all these kind of things, but they don't necessarily do the blueprints. So that's my first part of thinking like an architect is sketch more, right? Don't just make the blueprints. Don't be shy to sketch something out, place an emphasis. The second part that I feel that at least I find myself as an architect doing many times is be a tiebreaker. I don't see myself as being there to tell people what to do. Usually they know better than I do. But I find myself in situations a lot where people argue back and forth. And it's a little bit like in this picture, right? One person says, oh, this thing is a circle. The other person says, this is a rectangle. And I'm sure you've been in many of these discussions. It's like, oh, we need a serverless solution. Oh, we need a container solution. Oh, no, it's an API game. It's an ESB. No, it's a database. No, it's actually a data store, right? Whatever it is, you've been probably in many of these situations where people argue back and forth and back and forth. And there the role of the architect is, again, very useful. And that is showing people that there's more views, there's more points of view, there are more dimensions than people might be seeing. Right? Maybe it's a container-based serverless solution, or maybe they're two very different things. And maybe there are multiple dimensions to looking at this integration between the API gateway and the ESB, and it might be different parts of the system. So those are the things that architects do well. We tend to see more dimensions and get people out of these sort of A versus B, rectangle versus circle discussions. And not only do we see multiple dimensions, another, let's say, optical maneuver that architects like to do is to zoom out and zoom in. That has something to do with riding the architect elevator, right? The higher you are, the further you are zoomed out, and then you can go down to the engine room and zoom in. Now, the important thing here is this is not like a zoom lens on a camera where you sort of see the same thing a little bit bigger. When we zoom in, we see quite different things, like our systems and our organizational structures. They're kind of fractal, like these Mandelbrot sets are like watching these kind of animations where we really see different things, even though we're technically just looking at the same thing from a different level of abstractions. And what I find is that good architects are very good at this, right? And they understand that things might look different at different levels. One of my favorite anecdotes is there was some statistic about which cloud certification has the highest average salary, like the people who are certified in something. And there was something where we from AWS, for once, we're not on top of the list, right? We're just happy. You don't always have to be on top of any list. So it was some other cloud provider. People say, oh, if you get this certification, you have the highest salary. And everybody in the engine room was like, oh, that's fantastic, right? This is, I should get this certification. Well, if you zoom out a little bit and you zoom to the IT leadership or the CIO, they're going to have exactly the opposite reaction. They're like, oh, well, this is a supply and demand function. So if this certification fetches the highest salary, that means that people are really hard to come by. So if I go on this platform, I might have a skills supply issue. I won't be able to find the people to do the work for me. And if I find them, they're going to be very expensive. So this is a great example where being an architect, I'm not saying which part of view is right or wrong. I'm happy for people to be successful as architects, but I can also understand the business aspect of it. And that's a great example of being able to zoom in and zoom out, right? And see very different things. In this case, the opposite, actually, from the different points of view. So I think successful architects are very good at seeing that, and seeing the different levels in the end allows them to make better decisions. So if you want to see about what I think, what makes an architect, for me, it's a way of thinking. It's sketching, not doing the blueprints. It's seeing things from different dimensions, right? Sometimes more dimensions than others. And it's this ability to zoom in and zoom out. Now, if we zoom in a little bit and apply this to cloud architecture. Now, I work for AWS. I'm customer-facing role called Enterprise Strategist. So I meet with a lot of interesting people, usually IT leadership, CIOs, CTOs, sometimes CEOs, right? And we talk about the cloud. Now, these days, almost, we don't need to explain what the cloud is, that you can get a virtual machine very quickly. It's elastic, scalable, pay-as-you-go price tag. People gotten the memo. Everybody knows that. So how do you then explain why it's so important for their business, right? They might not be as interested in sort of the warm-up times of your serverless environment, or sort of how many Helm charts you've written last week, right? They want to understand different aspects. So over time, I started to explain cloud in a very different way. And to me, the most powerful way to explain cloud is that a IT leader's role, so we're like near the penthouse here, right? We're talking sort of CIO level. It's actually a pretty tough space to be. So, first message, be nice to your CIO. They might not always do what you like, but they're actually doing a quite difficult job. And number two is, the reason this job is difficult because they're usually caught between a rock and a hard place, right? On one hand, every large IT organization, or even sort of medium sizes, one of the mandates is always to reduce diversity, complexity, to harmonize, right? And that has to do with not drowning in excessive complexity. It has to do with vendor negotiations, consolidating, setting standards, often across business units, often across, even globally. I know many organizations where that is number one item on the IT strategy. We need to consolidate, we need to harmonize, we need to reduce complexity. Well, on the other hand, you have the business and today's business environment, right? And the business environment says, oh, we need to compete in different markets, we need to innovate, we need to be agile, we need to be customer-centric, we need to move more quickly, we need to be able to react to things like pandemics and shifts from from physical commerce to digital commerce, right? We need to react more quickly. We have many, many, many demands. Well, the CIO and the IT org is usually stuck in the middle between these two. Now, the good thing is that architects like to do is ask questions. And one of the questions here should be, now, why has this to be left versus right? Why are these two things opposites? The answer is relatively obvious. The answer is because there are constraints that make this opposites, right? If there were no constraints, like why can I harmonize and cost reduce, have cost reduction, but at the same time be highly innovative and agile? Well, the answer is you actually can. We said architects can see more dimensions. So this does not have to be on a single dimension. You can actually combine these two things. And I used to do quite a few workshops on the role of architects and the architect elevator. And we found quite a nice list of those items that used to be seen as opposites, right? That used to be seen on a single dimension. You have to pick left or right, but that were actually then, the advanced technology and our ways of working, ways of thinking. So we removed these constraints, the technical as well as sort of the more organizational, psychological constraints, and we found that we can actually have both. Now, this isn't a complete list, but I'm sure these will resonate with you. Speed and quality was the old, we do it quick and dirty. Of course, high levels of automation, continuous integration, many things we have allowed us to actually move more quickly and increase quality. We made things more repeatable. The second one, that's actually our topic for today, right? There's great examples of how you can standardize and still innovate. One of the easiest examples are the cloud platforms. If I'm in a customer meeting and I don't think it's quite punchy enough, I remind our customers and I say, hey, listen, the AWS you're getting is the same AWS your competitor is getting, right? There's no way of saying it a different way, right? It is a platform. It's highly standardized. We don't build a new thing just for you. That would not work. But at the same time, look back at the last decade and a half, right? Since AWS was born, it's been the biggest innovation driver and differential driver IT has ever seen. So there must be a way to standardize, to harmonize, but at the same time, boost innovation. Yeah, the list goes on, many other things. Maybe 20 years ago, people would have told you, oh, if I share everything openly, I cannot really have a viable business model. Well, then you have all these multi-billion-dollar IPOs from open source companies, right? So it's quite nice we busted that one as well. So here's great things that architects can do by seeing more dimensions and showing that some of these things are not on a linear one-dimensional spectrum, but you can actually have 2 dimensions and combine these 2 things. So let's take number 2. That's the topic for today. How do platforms do this thing that you can standardize and harmonize, but at the same time boost and improve innovation? Right, and then there's a famous quote which says, standing on the shoulders of giants, right? That's what platforms really are. You're not building something from scratch. You're standing on a platform. So the metaphor kind of works there. And you're building on top of that. I like to remind folks that we have invented many things in IT, but we haven't invented everything. Often we just reinvent things that other industries have already invented. Think about lean methods, etc. Comes from the automotive sector. And it turns out that platforms actually have also a long history in many industries, and particularly in the automotive sector. So if you look at many IT strategies, you will find a picture just like this. And I'm probably guilty of having drawn one of these as well, where you're like, oh, down here is the platform. This is all the common pieces we have, and we share them across all our different business units and product lines and IT systems. And on top, there's this fantastic sort of smaller grain. There's these blue boxes on top, right? I can make many different blue boxes and I can innovate. And here I have the magic. I have something harmonized underneath and I have something innovative on top. Looks fairly convincing on PowerPoint, but it is not as easy in reality. So let's look at where this idea has worked pretty well and what we can learn from that. And then we can fix this picture of actually saying that platforms is a lot more than just collecting some common components and making them usable across different applications. So automotive manufacturers have a challenge just like the software industry, and that is it's heavy duty engineering. A lot of safety critical systems in a car, right? And let's say this is still a combustion engine car, right? Many things you need to do around anti-lock brakes and engines and transmissions and suspensions and differentials and all those kind of things that cost a lot of money, right? They need to be safe, they need to be certified, right? They need to be environmentally friendly, they need to have good horsepower, they need to use little fuel, right? Many things they need to do. So in the end, it became uneconomical to develop this for each car model, right? To have like its own engine, its own transmission, its own chassis, its own suspension, right? Its own rear differential, its own anti-lock brakes, right? All these kind of things. The idea became pretty natural. Let's do these once and then make different car models based on that common technology. So this high investment in the standardization. Now this industry has the advantage of about 100 years of history underneath. So they understand pretty well what's common and what's not common, right? Making this dividing line. They have a pretty good history to look back on. And then what they do is shape different looks and feels of the car that are based on the same underlying technology. And that is indeed called a platform strategy. One of the most successful automotive conglomerates that has been doing this for a long time is Volkswagen. right? And if you buy a new Audi A4, and if you're lucky enough to buy one of these amazing Bentley thingies there, right, you are actually buying a vehicle that sits on the same platform. It's called the MLB Evo. And what that means is that the engine is longitudinally mounted, right? That's like their platform where the engine is in line with the car. They have another platform where the engine is the other way. And you can do many things with these platforms. You can build cars with different engine configurations. They can fit in. You can have an Audi with a big engine as well. And they can vary the length of the chassis and many other things. And the hat that you see in the end is very different. And that way you can address many different market segments, right? Although you're highly standardized or harmonized underneath. And this has actually been one of the success recipes for the Volkswagen Group for many decades. Now, I promised to look a little bit behind this picture that we drawn, the simplified orange and blue boxes picture. And it turns out that in Volkswagen's case, that picture has also evolved significantly. So it started with this hat and this platform where I said, I really have a base and just put a hat on top, right? I can make a Volkswagen Golf and I can make a Volkswagen Jetta, let's say, right? The hatchback in the trunk. So that's how this started. But then they found out that actually having the platform in one piece isn't quite as flexible as they wanted. So they started making the platform with smaller modules. And in the end, it almost became that the platform isn't sort of this one thing anymore. It is actually a collection of modules. Now, two comments to that. So A, that explains the B in this MLB platform. So that is B is Baukasten. That is actually like a toolkit. It's not like sort of a giant monolithic platform. It's actually a toolkit of things you can have. And that's how you can get the A4 and the Bentayga on the same platform. Well, the second comment is if you look at cloud platforms like AWS, right, we're also not one big monolithic thing. We're also a toolkit. So this is our first insight here. The orange box isn't one giant orange box. So it's actually made up of many smaller boxes, whether it's components of a car or whether it's one of the over 200 cloud services, individual services that the AWS platform has. So it's great here. We can learn from another industry. We didn't have to invent everything from scratch. The idea of this platform notion, we sometimes call it the undifferentiated heavy lifting, right? AWS, the common stuff is underneath, and then you can build differentiated things on top. That concept has fundamentally been proven in the automotive industry these days. Almost every manufacturer actually does that. So let's look at what's behind here. Like, how can you get this standardization and still make this an innovation driver? Because when I'm in a large enterprise, usually standards are not a very popular word, right? The standards folks, sometimes, unfortunately, then the standards are running under the label of enterprise architecture, and then people start to get to associate architecture with, well, these are the people who tell me what I can not do, right? Because I cannot use database A, I can only use database B, and I cannot use this versus that, right? Because we have these so-called standards that, in the end, constrain me, right? They're killing my innovation, they're killing my ability to build the system that I want to do. So that's unfortunately often the state in IT, but that doesn't have to be that way. So first let's look at why standards are not always something, or that doesn't have to be something that disables, like that sort of constrains you, but actually standards can be something that enable you. Standards can actually give you more freedom. And two of the examples I like to cite, the one is from 1904 in the city of Baltimore. Now, Baltimore, like 15 years ago, had a horrible fire, like over 1,000 buildings burned down. Okay, fire codes back then weren't what they are today, but they had a fire hydrants around the city. Now, of course, all the firemen from the surrounding cities came to help as the city was burning badly, and they found out that they couldn't do much. And the reason they couldn't do much is because the fire hoses wouldn't fit on the fire hydrants in the city of Baltimore, because the local fire hydrant manufacturers like to make their own couplings, right, to make sure people only buy the fire hydrants from them. So there you have a city burning and the firemen standing around basically having to watch the city burn down. Now, we learned from that, and since 1904, 1905, there's something called a Baltimore standard. There's a standard for fire hydrants that defines exactly what those couplings look like. side comment on this, right? If you've seen at least a US fire hydrant, they don't have a single coupling. They have two different sizes. In this picture, it's a little bit the other angle, but they often look like little people with a big one in the middle and two little ears on the side, right? And there's a good reason for that. The big connector is for the pump car, right? That's actually for the big hose, and the small connectors are for an actual fire spray hose. So the lesson learned there, the second lesson is standardization doesn't mean making everything the same. Standardization means understanding the architecture in the first place. So perhaps having a single database vendor for everything also doesn't make much sense. You need to understand what the use cases are and what your architecture is. And then for each box in the architecture, you can pick a standard. In the case of the fire hydrant, it turns out that two different connectors are actually the right architecture and the right way to standardize. One other great example is there's the ISO, the International Standards Organization. One of the very first standards they defined is the screw, right? The screw thread and nut for metric screws, right? And that means you no longer have to worry about, does my screw actually fit into the thread, into the nut? Now, the interesting thing that you notice with both of those standards is that they are connecting standards, right? They're what I call interface standards. They don't just define one thing, they're more define what actually fits together and how things fit together. And if you look at today's called the National Institute for Standards and Technology, NIST, many people might know this from some of the cloud definitions. They also have, it used to be called the National Bureau of Standards, right? Their book, they have a nice book about the history, and it's old. That's why, the pronoun here is still, for men, but because from the 60s. But basically what they're saying is the standards are there to accomplish something together, to understand one another. So a lot of the origin of folks really wanting to standardize something is about interconnectivity, right? That's why it makes sense, screws and fire hydrants. And if you look at IT, right, the most successful standard we had in the past decades is HTTP, right? Without HTTP, I wouldn't be running my presentation in a browser. We wouldn't have this video conference, right? There would be a lot of things that we wouldn't be able to do without HTTP. And HTTP is an interface standard, right? And what it did is it standardized one element, but because one element, the protocol is standardized, you can have any web browser with any web server. Just like you can have any fire truck with any fire hydrants, or you can put any M3 screw into any M3 nut. So the fundamental part of understanding platforms is to see that by standardizing the connecting elements, you gain variability of the endpoints. You gain the ability to innovate by standardizing some things. Oddly, that is different than what a lot of organizations do with their standards. They somehow try to standardize the endpoints, and that is totally not a platform strategy, right? That will not lead to this nice effect, what I call actually the platform paradox. I never shy of sort of a punchy way of putting it, right? If you need to convince people that you can be standardized and still creative, A4 paper, outside of just the US is, what we all use for paper sizes, 210 by 294 millimeter. And if you put two together, you get A3, and ultimately you get A0, which is exactly 1 square meter. Very nice standard. Now, I have not found one person who told me, it's like, well, I would like to be so creative in my drawing, but I really cannot because you guys have given me this odd paper size, right? Doesn't happen, right? So one of the most prevalent standards we have on the planet, right, in the end, still allows you to innovate, or maybe even more so, because you don't have to argue about how big is the envelope, how big is the paper, how big is the drawer, how big is everything. It's just done for you. You can actually start innovating and drawing. So another punchy example about how standardization actually helps you. Right, and there's a nice quote, right, that brings us back into the world of IT, how this standardizing to increase innovation works. This is from Peter from ThoughtWorks, right? It's very nice. Like the platforms are a way to centralize the expertise. Like there's things in the platform here, like building globally distributed transactional databases, right? That is like the car engineering. That is something you want centralized, right? You don't want to do that 20 times. It's difficult to do it once. We can surely attest to that, right? But then you want to decentralize the innovation that you're doing for your customers. They can be internal customers or they can be external customers. So this is a nice way to express why platforms are so successful. It allows you to centralize some things, but decentralize the innovation. So that should convince you that platforms are good things. So the next question is, of course, well, how do I make a good platform? I hinted at this picture with the blue and the orange box isn't quite the whole story. So let's go fix that. As so often we find as architects that the key properties of a system are not in the boxes. You know, the boxes are nice and we know how to build the boxes and the things inside the boxes, but the key property is usually between the parts. That's how the behavior of the system is defined. And that is the same thing here. What is missing here is how do these blue boxes actually interact with the platform? And I think that's where a lot of organizations I see who build in-house platforms, that's where they struggle. You know, they sometimes take their old IT services and say, oh, because we have a new buzzword, I'll now call my IT services the platform, or my core business application is now a platform, very common maneuver. And it doesn't get this nice paradox. It doesn't boost innovation. And one of the reasons is that the things in the middle are often not given. So the one thing is a platform needs to have low friction. If it's difficult to get onto your platform, people won't get on it. They have alternatives, and the platform won't grow. A platform is a scale business underneath. Right? The bottom half of this picture is about scale, and the top half is about speed. Yeah, I like to call this economies of scale and economies of speed. And a platform is the magic connecting element between the two, but only if the friction of using the platform is low. Right? If it's high, people won't get on the platform. The scale effect doesn't happen. You can't maintain the platform, and the whole thing goes downhill. The platform also can't be a complete black box. So let's say something goes wrong on the platform, or maybe you used it improperly, or miss performance limitations. You know, a million things can happen. You need to be able to have enough transparency. You know, this can be logs, this can be diagnostics, right? You need to have ways to say, at least, is it me or is it the platform? Right? Is something wrong underneath or something wrong in my part? And ideally, you want much, much more information than that. So you need to give transparency. And if you look at the cloud platforms, obviously I know AWS best, right? With CloudWatch, etc., right? There's a lot of transparency that you get, and the service status of all the different services. You can quickly see, okay, the service is running, so it must be me. On rare cases, you might see, oh, this is something global going on. It's actually not me. So the transparency is there. And the last one that has to be there is the shared responsibility, right? You cannot say the platform should fix all my problems, right? This sometimes happens in IT as well. You know, if you have world's most monolithic, unsecure, unscalable, and buggy application, and you move that to your favorite cloud platform, well, you have a little bit more fancy and most monolithic, most unscalable, most brittle, most buggy application still, right? The platform cannot fix all problems for you. It is a shared responsibility model. You are doing your part, and the platform is doing its part. So it's not a blame kind of game. It's like, oh, you made this platform and made all my problems go away. Why does it not scale? Right? That might be your half of the problem. So there's three key elements in here that are often left out in this orange boxes and blue boxes diagram that are key to making this platform work. There's three more, and I call it the 3 E's. What I have seen, and this is what I'm writing the book about, what I have seen that makes platforms successful. The first E is similar to the low friction. A platform has to enable. It cannot disable. A lot of traditional IT platforms kind of make things a little bit more cumbersome, and you have to follow this standard and that process. That doesn't make a platform. A platform needs to make your life easier, right? Or faster, quicker things to do. It needs to enable. Good platforms are also not static. AWS started with EC2 and SQS and S3, right? Like three very fundamental and still very popular services, right? But it didn't start with 200, right? It evolved over time. Now it needs to evolve more slowly than the blue boxes on top, right? That is clear. The rate of change has to be a bit lower in the platform than on top, but it does evolve. And it evolves either on feedback, or better yet, it evolves based on how you see people use the platform. Simon Wadley, very clever guy, he calls this platforms are future sensing engines, because as people build on your platform, you can see what they do, and that gives you insight on how you can evolve the platform. And the last one is the platform that you're going to build, you should not build from scratch. You should build on top of another platform. You should embrace underlying platforms. So you might build an in-house platform on top of an AWS or another cloud platform, right? Your platform doesn't need to go all the way to the base, right? You should embrace what is already there and build a platform only for what is not already there. right? And this is a nice way, I'm not going to have to read through this, right? There's a nice way of comparing and contrasting. So a classic IT service, okay, I painted a little bit black and white here perhaps, right? But sort of the typical IT service out where things are a little bit slow, they become a bottleneck, right? There's higher friction, right? Adding a new service is relatively expensive. You need to file a ticket and see what happens to a successful platform where it's basically the opposite. It's quick, it's transparent, it's self-service, it is customer-centric as opposed to process-centric, right? So there's actually, well, if you wish, it's almost the exact opposite. It looks like an underlying element that is common, but the way you interact with it, the way it evolves, the way it's designed is actually completely different. So this maybe as a major lesson, building a platform is a different business. You don't just take your common shared services and now call them a platform. It is a different way of working, a different way of thinking. So for final part, dive into now, okay, I'm convinced I'm going to build an in-house platform. Now, what design decisions and what design trade-offs and what options do I have? Right, let's put our architect hat on and see how I go about making such a platform. Now, the first key decision, we said platforms embrace, right? They sit on something else, in most cases, a cloud platform. The first key decision you have to make is, as this base platform grows, and it will grow, whether it's the reInvent or any other vendor's annual event, right? Ours is coming up. There's going to be like a gazillion more things in the platform. It will grow, and that is a great thing, right? The platforms evolve, and so does the base platform underneath it. Compared to rising ocean levels, maybe not as happy a metaphor, but it works in this case. So let's say, right, the thing that you're sitting on actually increases, goes up. Well, the first decision you need to make is, are you going to keep your platform stable? Are you going to keep your platform the same? So you might have built something that is now part of the base platform. You're like, well, I made my customers use what I have built, right? So I let them continue to use what I have built, even though it's in the base platform, right? That is a reasonable argument, but be careful, because as the ocean levels rise here more, you might actually be underwater. It might be the easier route, but also the more dangerous route, because the economics of you replicating something that the base platform can do now are usually not good. The opposite is you make what I call a floating platform, right? As the platform does things that you needed to do in the past, you just switch over. You say, oh, that's great. Now I don't need to do it anymore. You let the platform do it, and you build new things, right? You have now capacity to layer more things on top that are great for your business that the base platform might not have yet. And we did this when I was at Allianz. It was very clearly so. We built back then an on-premises platform for rapid application delivery. And 5 years later, my friends came like, oh, look, they replaced everything you built with AWS. And I said, well, that's perfect, because we don't need to build it and maintain it anymore. And B, you know what? It actually means we weren't as dumb. Maybe we built exactly those things that the cloud platforms actually built later on as well. So our strategy was 100% in line with the cloud platforms. I'm like, perfect, right? I wanted to build a floating platform, not a sinking platform. So first design decision, are you building a submarine, right? Something that can operate well underwater, or are you building a boat, something that floats with a platform underneath? Very, very important decision. If there's confusion about this, you might get a lot of disappointment with your users, your management, your economics in-house. Fundamental decision. Now, why you build platforms, going to watch the time here a little bit. There's a lot to say about platforms. Why you build platforms also varies. And the second major decision is, be very clear why you're building it and what mechanisms you're using. So hiding some complexity, being able to make smart defaults. So let's put it this way, right? AWS, we need to support anybody on the planet. Like your in-house platform does not. It only has to support your business. Now, you can make more assumptions than we can. It's very clear. That's the platform layering fundamentals. Now, that means that you might not need all the settings that the underlying platform has. So you can combine some things. You say, well, I only ever use my API gateway with a Lambda function. So I make some things, some automation that you say, I make this a one component basically. Make me a Lambda that has sort of an API gateway on front of it, right? Because I always use them together, right? And maybe there's an event bridge in the middle or something, right? I just like, okay, for me, this becomes one thing. And now rather somebody than having to implement and instantiate 3 different components, they just have to instantiate one. Or you can make defaults for many parameters, right? And this simplifies things. It reduces the learning curve. It helps people make fewer mistakes, perhaps, right? Other people make platforms to reduce friction, right? I want to speed things up, make software delivery easier and quicker. So the cloud does a lot of this, but there's surely things that you can still layer on top. You might also build things that the platform didn't have. That's what I did at Allianz some years back. The cloud platforms weren't as far as they were today. So we built the things that we couldn't easily have, like we wanted the fully automated CI/CD pipelines at the time. So there are choices here, and this is architect thinking, right? These are very technical, right? Like default settings, automation, building new components, wrappers, right? These are the technical mechanisms we have on the right column, but we show how we relate them back on what's our intent and how does this match to a business incentive. This is a classic architect elevator maneuver, getting these things all on one spreadsheet. You might have more rows, and then making clear which one are we picking, like your business, right? What's your objective here? Because if those don't align, I always say if the two tunnels don't meet, drilling faster won't help you, right? You got to make sure these things align, that the business's expectation, what your platform will deliver, matches actually your implementation guideline and the mechanisms you use. Classic elevator maneuver to make sure your platform does the things that were actually expected from it. Third design decision is, what does your platform look like? And I wrote a blog post. I'm sure you can Google for it with this title. If you Google for platform and fruit salad, you surely find it. It's on the architect elevator side. The reason is, some platforms are just collections of existing things. You say like, oh, I have like 5 different things and I bundle them essentially into a platform. That is the fruit basket model, right? You get 5 different fruit, they come in one basket. It's a little convenient that they come in one basket. You only need to carry one thing, but at the end of the day, if you pick something from the platform, you just get one fruit. On the other hand, our more sophisticated platforms, they are more like fruit salad, right? Where things are sort of prepackaged, easy consume, bite size, in the right ratio, right? They're put together for a different use case. You can have a great snack and have all the different fruits that with a basket you couldn't have. And if you go to the supermarket, you find that actually the price per weight of the fruit baskets, for the fruit salads, is quite a bit higher, right? Because they're purpose built for a specific use case. You can make more money selling fruit salads than fruit baskets. Both are useful in a way, right? The fruit basket might be easier to start with. The fruit salad is often more purpose built. If I want to go on a picnic, I do want the salad, not the basket. So important decision for you, where on the spectrum are you going to be with your platform? That means sort of how much do the pieces interact? Is it just a collection of independent parts, or is it something that is actually making a cohesive whole? And if you look at the cloud platforms, things like CloudWatch or IAM, right, the identity and access management, those are great things that highlight to you that the cloud platforms are actually much more fruit salads, right? They're not just a collection of random services. They are things that are meant to fit together to support specific use cases. And then the last message I have here in terms of guiding you in building your platform is an abstraction, right? We said it's part of it is hiding some complexity, making some decisions for you, taking some of all the dials and knobs away. So you're abstracting some things away, and people will enjoy that quite a bit because you made their life easier. You were hiding some complexity without constraining them too much. However, when something goes wrong down in the engine room, this is my favorite old cartoons, right? This is actually from Talk on Interface, an old great book about GUI design, where the guy's in the hotel lobby and suddenly, something goes wrong and this stovepipe from the engine room comes back out, right? He gets teleported back into the engine room, right? That can easily happen. Failure often does not respect your abstraction. When something goes wrong, people will be like, the whole abstraction goes away like a nice dream, and people will struggle because all the complexity that you hid from them are coming back out. Now, there isn't a magic recipe that I've found to avoid this. So the best guidance I have here is to look at, to be aware of this problem and give folks sufficient transparency. Don't burden them with all the complexity, but give them sufficient transparency that if there's a problem, they can understand what the problem is. So the platform cannot be a complete black box. So hopefully that gave some ideas on the topic of platforms. There's a lot more to say, and I have a lot more to write about the book. So just recap quickly, right? One of the key things that we see the cloud can do is it can break these contrasts, right? And one of the contrasts was standardization, innovation. Platforms are the key vehicle that make that happen. Where it's from the automotive industry, so we know it works well, but we also find that it's more than you're drawing a picture with a big orange box and many blue boxes. It is really about how you interact with the platform, make sure you have the low friction, you have the transparency in there, and also make sure your platform enables as opposed to disables, make sure your platform evolves and your platform also embraces things underneath. And then as you go on to build such a platform, there are some key design decisions, and who would have thought that knowing about fruit baskets and fruit salads is going to help you make your platform strategy. So with that, I invite you to have a register for the book. I'll do my best to finish that, and I look forward to your questions. Thank you so much.
Thank you very much, Gregor, and thank you for getting up and speaking to us live from Germany. So I do have a question for you. This one's from Reese, and he says, can you dive in a little bit more into sinking versus floating platforms? I think I missed the point there, and I guess a few others did as well. Okay. Can you perhaps elaborate a bit on that one?
Yeah, the submarine versus the boat, right? So, and I made the names intentionally punchy so that people think about carefully. So as you build a platform on top of a base platform, let's say you're 5 years back and you found that you're running an AWS or any other cloud platform, and you're building some things that the platform doesn't have. So let's say you built some code inspection system, right? Very sensible thing to do. Now, then last year, AWS released Code Guru. Right, so an AI-enabled code inspection system. At that point, you have a decision to make, which is, do I abandon what I have built, right? And I built it for good purpose, it served me well, I have some investments in there, but now I say, well, I can get it in the platform, so I abandon it. And now I don't need to maintain my code inspection thing anymore, so I have capacity to make the next new thing that maybe the platform doesn't have yet that I might need. That is the floating platform, right? You shed things underneath, right? You float up with the capabilities of the platform, and you always only build things that are not in the base platform. Now, the nice thing is you optimize your resources. You're not trying to rebuild things the base platform does. That would be denying the embrace principle. The downside, if you wish, is that your customers, right, as you float, your customers, your surface starts looking slightly differently, right? In the past, you had your own code inspection tool. Now your internal customers are asked to use Code Guru, right? So, and those are the trade-offs you need to make. I'm not telling you which one is right or wrong. I'm mostly encouraging you to be very explicit about what your choice is, because let's say you're floating, your management might come to you, like, oh, you built this thing and spent all this money, and now you shut it down 3 years later. And having been clear about this upfront, you say, yeah, that was the plan all along. We never set out to duplicate anything that the cloud platform already does. So we're actually happy to shut it down because we no longer have to maintain our own version. We can use the cloud service. So that's why this decision and making this decision explicit is useful. So there's no misunderstandings about the life cycle and the financials of your in-house platform. So I hope that clarifies a little bit.
Okay, hope that helped out there, Reese and other voters. Next question from Ashley. Could you briefly discuss the trade-offs between proprietary and public platforms and standards and platform lock-in?
So lock-in is a longer topic, right? So as you use a platform, right, you are dependent on that platform to some extent, right? You cannot use a platform without having any kind of dependency. So lock-in is a little bit, I don't like the term as much. I always say it's really about switching cost, right? Like how much, if I, for whatever reason, need to switch from one platform to another, how much will that cost me? That's a problem that we had for, or at least a discussion point we had for a long time. So there's two opposing schools of thought, right? The one is having the option, and I mean, it's a longer topic, having the option to switch platforms is always valuable, right? It's good to be able to switch. However, being able to switch also has a cost, right? This option of being able to move from one platform to another is not free. And the key cost that you can have is one is extra complexity, right? There's some folks who say, oh, I just layer another platform on top of all the cloud platforms, right? And now I have this uniform platform, and now I can actually switch back and forth. With that, though, you have yet another layer in your system. You definitely increase complexity. And what you also did is now you're depending on that platform, right? So you just, basically, if you like the term lock-in, you're now locked into one thing versus the other. And then sometimes people say like, oh, it's open source, so I'm not locked in. It's like, no. Read my article on Martin Fowler's site about lock-in, right? Very popular article is you might not be locked into a vendor, but you're locked into a technology, into an architecture, into a skill set. You're still locked into a gazillion things, even though it's open source. So be aware of the cost. My experience is the biggest risk is the risk of underutilization, right? You go into the cloud and you're saying, oh, I have all these fantastic services, right? I have serverless API gateways, databases, all this kind of stuff I can have that I don't need to operate, but I'm not going to use it because the other cloud provider doesn't have the exact same thing. So now I'm kind of sort of build my own and just manage my own. You basically undone most of the benefit that you got in the cloud. So my advice there is, use the cloud for what it is, be successful with that, keep the complexity down. And if it turns out that you need to make a change, the higher your velocity, like the more high speed your organization is, the easier it is going to be for you to make the change as well. Not all problems have to be solved with a architecture structure layer. If you have a well-greased software delivery organization, moving from one platform to another isn't going to be that much of a problem. So invest in your velocity rather than letting yourself be slowed down by complex constructs that might solve some logging problem somewhere in the future or maybe not.